Good morning. This is Mrs. Bharati Kamboj from Guru Nanak Girls College, Yamunanagar, Haryana, and the topic of my discussion today is Raman Effect and its quantum theory. Raman Effect is when a parallel beam of monochromatic light of some given frequency falls on a molecular medium which does not absorb light, it gets scattered through the medium. जब मोनोक्रोमेटिक लाइट किसी मॉलिक्यूलर मीडियम पे फॉल करती है तो अगर वो मॉलिक्यूलर मीडियम लाइट एब्जॉर्ब नहीं करता तो लाइट उसमें से स्कैटर हो जाती है. The scattered light, in addition to the original frequencies, also contains frequencies, some of which are higher than the incident frequency and some of them lower than the incident frequencies. This is known as Raman scattering or Raman effect. स्कैटर होने के बाद लाइट में कुछ एक्स्ट्रा फ्रीक्वेंसीज आ जाती हैं. कुछ फ्रीक्वेंसीज इंसिडेंट फ्रीक्वेंसी से ज्यादा और कुछ फ्रीक्वेंसीज इंसिडेंट फ्रीक्वेंसी से कम. इस इफेक्ट को रमन इफेक्ट कहते हैं. The Raman lines having frequency lower than the incident frequency, they are known as Stokes lines, and the Raman lines having frequency higher than the incident frequency, they are known as anti-Stokes line. Stokes lines, it is observed, Stokes lines are much more intense than anti-Stokes line. Here we can see the graphical representation of the lines in a Raman spectrum. In the center is the line which corresponds to the incident frequency. This line is known as Rayleigh line. Then these are a group of lines having frequencies slightly higher than the incident frequency. These are known as anti-Stokes lines. And on the left side, these are a group of lines which have frequency slightly lower than the incident frequency, and these are known as Stokes lines. Next, let us see how this Raman effect is explained on the basis of quantum theory. Let us have a light of frequency nu which is incident on a molecular medium. Then we know, according to quantum theory, light consists of photons. Each photon has energy E equal to h nu, where nu is the frequency of the light, frequency of the photon. Then as photons collide with the molecules of the medium, then there will be collision with the photons and the molecules. If the collision is perfectly elastic, then there will be no change in the energy of the photon or the molecule. No energy is exchanged and the photon gets scattered without any change in its energy. This is known as Rayleigh scattering. If during the collision between the photon and the molecule, energy is exchanged, then the photon will get scattered with a changed energy and hence a changed frequency. In that case, the collision is inelastic. So, three things can happen. The photon collides with the molecules, gets scattered without any change in its frequency because the collision was elastic. But if the collision was inelastic, the photon will get scattered with a change in its energy and a change in its frequency. The frequency may increase or decrease depending upon whether the photon has gained energy or it has lost energy. The change in energy of the photon corresponds to is equal to the change in energy of the molecule. अगर photon energy gain करेगा तो molecule energy lose करेगा. अगर photon energy lose करेगा तो molecule energy gain करेगा. And therefore the change in the energy of the photons is equal to change in the energy of the molecules. That means difference between energy of two energy states of the molecule. and the change in energy is E equal to h nu dash, where nu dash is the change in frequency of the photon. So if the molecule gains energy delta E, then the scattered photon will have a reduced energy. Already it had energy h nu, so its new energy becomes h nu minus delta E, that is h nu minus nu dash. So iski frequency kam ho gayi. This is known as Stokes lines. This gives us the Stokes lines. On the other hand, if the molecule loses energy delta E, then scattered photon will have increased energy. So its energy will become h nu plus delta E. So frequency will also increase from nu to nu plus nu dash, and this gives us anti-Stokes line. So बहुत सिंपल सी एक्सप्लेनेशन है. अगर कोलिजन हुआ मॉलिक्यूल और फोटोन के बीच में, तो मॉलिक्यूल ने एनर्जी जितनी भी लूज करेगा उतनी ही एनर्जी फोटोन गेन करेगा, या अगर फोटोन एनर्जी लूज करेगा तो मॉलिक्यूल एनर्जी गेन करेगा. एंड that's the reason for production of extra frequencies, Stokes lines and anti-Stokes lines. Now it is observed that the intensity of Stokes lines is much higher than the intensity of anti-Stokes lines. Stokes lines हमारे पास क्यों आई? जब कोलिजन के वक्त फोटोन ने एनर्जी लूज की और मॉलिक्यूल ने एनर्जी गेन की, तो जब मॉलिक्यूल एनर्जी गेन करेगा क्या होगा? वो लोअर एनर्जी स्टेट से हायर एनर्जी स्टेट में जंप कर जाएगा. So the intensity of Stokes lines is proportional to number of molecules in the lower energy state. Anti-Stokes lines कैसे आई थी? फोटोन ने एनर्जी गेन की थी, मॉलिक्यूल ने एनर्जी लूज की. सो मॉलिक्यूल एनर्जी लूज करेगा तो क्या होगा? द मॉलिक्यूल विल transition from higher energy state to lower energy state. So the intensity of anti-Stokes lines is proportional to number of molecules in the higher energy state per unit volume. Now we know normally any medium exists in its lower energy state, that is its ground state, and therefore the density of molecules is more in the lower energy state. Therefore more molecules jump from lower energy state to higher energy state, and hence the intensity of Stokes lines is much higher than the intensity of anti-Stokes lines. Now the energies corresponding to the Raman frequency shifts are found to be energies associated with transition between different rotational and vibrational energy states of the scattering molecule. We are familiar that a molecule has many kinds of energy levels: rotational energy levels, vibrational energy levels, electronic energy levels. So when a molecule transitions from one energy state to another energy state, the change in energy corresponds to the energy difference between any two energy levels, maybe rotational energy levels or vibrational energy levels, and accordingly the change in frequency of the photon, that is Raman shift, corresponds to this energy difference between energy levels, rotational energy levels or vibrational energy levels. So अगर ट्रांजिशन दो रोटेशनल लेवल्स के बीच में हो रही है, जो जंप कर रहा है इलेक्ट्रॉन, अगर वो दो रोटेशनल लेवल्स के बीच में जंप कर रहा है, which correspond to a single vibrational energy level, then it is pure rotational shift, and it is very small because the energy difference between rotational energy levels is very small, so it is difficult to observe in gases. On the other hand, if the transition takes place between two energy levels corresponding to two different vibrational energy levels, then the energy difference is large and it can be observed in gases, liquids and solids. So let us first discuss pure Raman rotational spectrum. If the electron or molecule transitions between two energy levels, two rotational energy levels corresponding to the same vibrational level, then the change in energy or the term value is given by Fj equal to J plus 1 centimeter inverse. What is J here? J is total angular momentum of the molecule and B is some constant. When the jump takes place, when this transition takes place, then the selection rule to be followed is that J changes by either 0 or plus minus 2. तो अगर J की वैल्यू में कोई चेंज नहीं आता तो हमें फिर ओरिजिनल फ्रीक्वेंसी मिलती है स्कैटर्ड लाइट में, which is known as Rayleigh scattering. And if J changes by either plus 2 or minus 2, then we get rotational Raman lines, that is rotational Stokes and anti-Stokes line. And the rotational Raman shift in frequency is given by the frequency change or the frequency of the Stokes lines and anti-Stokes lines. That change is given by this expression. We can subtract the different term values having different J values and we get delta nu rotational equal to 4b J plus 3 by 2, where J can be 0, 1, 2, 3 and so on. Now if the transition is between such energy levels which correspond to two different vibrational energy levels, then the vibrational energy levels of a harmonic oscillator are given by G nu equal to nu plus half nu oscillations by C centimeter inverse. This is the term value, and the selection rules followed here are delta nu is equal to plus minus 1, plus minus 2, plus minus 3 and so on, and therefore the total term value when the electron jumps between two rotational energy levels corresponding to two different vibrational energy levels is E equal to G nu plus Fj, that is nu plus half nu oscillation by C plus B J plus 1. And the vibrational rotational Raman shift in frequency is given by delta nu. We subtract the term value corresponding to higher quantum number from a lower quantum number from one containing higher quantum number, and these are the frequencies of anti-Stokes lines and Stokes lines that we get, the change in frequency for anti-Stokes and Stokes lines. So that is how we can explain Raman effect on the basis of quantum theory. Now here are some interesting facts. Sir C.V. Raman, Chandrasekhar Venkat Raman, we know he was an Indian physicist. In 1921, he had gone to England to attend some conference, and while his way back from England, he was traveling through sea and he observed the beautiful blue color of the Mediterranean sea water. And he started wondering what could be the origin of this beautiful opalescence, this phenomenon. He was already aware of Lord Rayleigh's explanation that the blue color of seawater is due to reflection of blue sky in the water. But somehow he did not agree with that explanation. So he started his own line of research, and this curiosity of his led him to discover a new scattering phenomenon which we now know is known as Raman effect in February 1928. And for his work he earned Nobel Prize in 1930 in physics, and he was the first Indian physicist or Asian or non-white person to receive Nobel Prize in any branch of science. Now, the end of this discussion, we are able to answer these questions. What is Raman effect? What are Stokes and anti-Stokes lines? Explain the quantum theory of Raman effect. Please do these questions in home assignment. For more such videos, like, share and subscribe. Keep watching this channel and don't forget to press the bell icon on top of your window so that you may be notified when I upload my next video. Thank you so much. Have a nice day.